Welcome to this seventh webinar. My name is Gulven Prudhomme. I'm the sales manager in NKE Instrumentation. And this morning we are talking about the new multiparameter probe WiMo. So we can wait a couple of seconds. Some of our or your colleagues are now joining us. Okay, so let's go for this new webinar. Today we are talking about the WiMo Probe, and the focus is on the applications. On the previous webinar we explained in detail the technical parts of the probe. You can see this previous webinar on our YouTube channel, and we invite you to have a look on the different webinars we did since the beginning of this pandemic, beginning of the year. So this new multiparameter probe is the fourth generation of multiparameter probe in NKE. We have designed this probe to be very flexible and to be adaptable for all applications. So a couple of words before on the company. Some of you know NK Instrumentation for sure, but the company is now quite with a big experience. We were created in 1984, means 70 years of experience in the measurement of the quality of the water. We are specialized in the study and fabrication of instruments for water measurement and environmental monitoring. The company is 40 employees with a big and a large, strong engineering office, 15 people working in this department. We also have our workshop with 14 people and of course all the administrative employees. We are very well known on the ocean coastal applications for the monitoring of water, and since now more than 10 years we are also doing the monitoring in fresh water. So as you can see on the pictures, all the different departments are located in the same place, our engineering office, our workshop, our laboratory. Because this is one of our strong force, we calibrate all the channels of our equipments before delivery. And in some application, in some case, we can also do the installation of those equipment on place, on the site, and do the maintenance. This is the reason we have two vessels, two boats, to do those installation and maintenance. Of course, we are using our own boat when it is not so far away from our head office. Otherwise, we are loaning the equipment locally. So now let's talk about the WiMo Probe. First, we propose, in fact, two models. Two models of probe, one with 4 locations. This is the picture you can see on the middle of this slide, and a second version for more, let's say, sensors or parameter with seven locations. So the number of locations is the number of plugs that you can have on the probe. Maybe you can see the mouth there. So here you have 4 slots. For example, this is what we can find here on the small one, and on this one, the 7 slot to put up to 7 sensors. So this is fully customized. That means you can adapt the different parameter or the different measurement you can do with the probe depending of the number or depending of the sensor you install on the probe by itself. This is all sensors are plug-and-play sensor. That means you don't need to do some specific parameters or programming to recognize the sensor. So when you plug it on the probe, automatically it is recognized by the probe, and the probe knows which sort of measurement we can do with it. One of the big change before compared with the previous probe we provide, this is the energy. Actually, on the WiMo Probe, to avoid all problems of transportation, we are using alkaline battery, and we have the same level of performance within the lithium battery. So we work a lot on the electronics in order to have a very low consumption of energy. We have the possibility as well to use rechargeable battery. In some case, sometimes it would be better to recharge the battery than to replace the battery. So we have this possibility to provide rechargeable battery as well. Of course, for long-term deployment, one of the let's say the problem is the falling on the sensor that makes some drift on the measurement. In order to avoid this problem, we have the possibility to propose an automatic wiper to clean the optical sensor. So this wiper is a central wiper. You can see it on the two models here. One is here, the second one is here on the center. This automatic wiper is, we said, intelligent because it recognizes also which sensor it has to clean. Because some of them is not necessary to clean, it doesn't change anything. And in this case, it's coming on the sensor, but only on the optical one. We also have a large storage of memory to this probe, up to 15 megabytes. So that means for long-term deployment, we can have several months of memory available on the probe. Regarding the communication, we have the possibility to work with different mode, in fact. Of course, the basic mode is data logging. So that means you leave the probe on the water for a time, and it is doing the measurement. The measurement is all the data are kept inside the memory, and you recover that manually with a Wi-Fi connection. But most of the application, and you will see that later, we need to have real-time communication. So by this way, we have the possibility to connect the probe to the, let's say, the systems that can give the data available on screen. One of them, let's say, actually the most popular is the GPRS1 by using a 3G and 4G modem. Just insert a SIM card in. We also have this same, let's say, transmission box, but in this case with a satellite modem, in order to be connected to the land, even in a very far place. Or we can also connect this probe by Modbus. So that means with a cable, and in this case it could be integrated on instrumented buoy, for example. So this probe is able to be dive up to 250-meter depths. This is also something that we changed before with our previous probe. Programming. Programming is something very interesting because we propose with this probe to be connected by Wi-Fi. That means by a different terminal like a smartphone, tablet or laptop. We just create a Wi-Fi connection between the terminal in order to be in connections or to be able to program this probe without any specific software. So this is very nice and very friendly application. And of course a large range of sensors. So just a look on the parameters. Natively, we have two parameters available on the probe. This is temperature and water pressure. So the sensors, those two sensors are integrated on a probe by itself. As I tell you at the beginning, we can customize this probe following the need and following the application. After that, you have just to connect different sensors like conductivity, turbidity, dissolved oxygen, pH, fluorescence, where we have several sort of fluorescent sensor like chlorophyll A, phycocyanin, phycoerythrin, sedum, hydrocarbon, for examples. And some of other parameters are calculated. So, for example, when we are measuring the water pressure with the internal pressure sensor, we can also calculate the depth. When we have the combination of conductivity, temperature, and pressure, we can calculate the salinity, and so on. So we have the possibility to provide different calculated parameters like chloride, depth, salinity, sound velocity, specific conductivity, in certain cases it's very interesting, and total dissolved solid. So now I said multi-application probe. What does it mean? That means we can use it in several fields, in fact. Of course, one of the, let's say, the biggest are the sea environment monitoring with different applications. We can see that just after this slide. And the freshwater application. So both of those two fields cover, let's say, 95% of the different application of the multiparameter probe. Just a look of some of them in freshwater for industrial discharge monitoring, public construction monitoring. This is due to the new regulation to measure the impact on the water when we are doing some construction. Of course, also in channeling and sanitation monitoring and scientific experiments. We have several applications for environmental monitoring, like big networks to follow some place, like the estuary or big rivers. Coastal application, mostly in harbor, where we have to do some monitoring when we extend or when we are doing dredging, for example. So this is also large application of the WiMo. Of course, fishing, oyster farm, aquaculture. It's also a big, let's say, big numbers of applications for this probe. And finally, we are also providing this multiparameter probe in the wind offshore environmental monitoring during the construction in order to follow the turbidity in real time. So what I suggest is to have a look on some precise application. The first one is in industry. We had a request from a plant that is manufacturing tobacco, and during the fabrication of tobacco they need water, a large volume of water, and they use the water coming from a river. Because of some reject inside the river, the authority asked this plant to do a real-time monitoring, and they had this request to measure the temperature in real time. But this measurement point is quite far away from the plant. So they needed to have a system very simple to be installed, with a real-time monitoring, with a real-time communication with the plant, and as small as possible, because it's far away from the plant and nobody can have a look on this instrument. So we propose to a small buoy where we have a multiparameter probe with only one parameter measured, it's the temperature, and a GPRS connection with the plant in real time. So we transferred the data every hours to the plant in order to measure this parameter. So now it's running since a long time, several years, and we have a really good result on the disponibility of the measurement. Another example is the public construction monitoring. Here it was in rivers again, but the project is a construction of a big highway, and this highway across 5 rivers, and the authority again asked to monitor what will be the impact of this construction on the rivers. So we install a network of 10 multiparameter probe, 5 before the construction and 5 after the construction, in order to see this impact. The construction was for a long time, more than 4 years, because it was some of the rivers are big rivers, so with the construction of big bridge to cross the river. And we provide the data. It was turbidity, dissolved oxygen, and chlorophyll A for 5 years to the construction company in order to measure this impact. As soon as a certain level was overpassed, we sent also alarm in order to the construction team to decrease or to reduce their impact on the water. Another example in freshwater is a scientific experiment. We work in this case with l'École Nationale Supérieure in France. This project is the construction of artificial lake in order to recreate mesocosm inside, and to follow this mesocosm, we had to provide a multiparameter probe to do some profile inside the lake. So we have provided a solution with a winch, and at the end of the cable we had in fact with those multiparameter probe to measure temperature, depth, dissolved oxygen, chlorophyll A, and pH. And we are doing those profile 24 hours a day. So the frequency is every hour we are doing a profile in order to measure the different parameter at each 5 centimeter let's say layer on the water, in order to give different parameters in real time to the scientist. We also provide the 2 biggest networks in France, named Magest and Civelle. The first one, Magest, is a big network with actually 8 multiparameter probe along this long estuary from the Atlantic coast to inland on the center of France. Those multiparameter probe are measuring salinity, turbidity, dissolved oxygen, and some of them are measuring also the fluorescence, the chlorophyll A. This is, we can say, a scientist application, but not only a scientist, because this, let's say, measurement is, or this network is for all the parameters are shared with the company or the industry along the rivers. The second network is the same. This is Civelle, but another river on the Loire River. It is composed with actually 7 multiparameter probe. And for both of them, next year we will add 3 new points. So they are actually the biggest networks we have in France to follow the quality of those rivers. For coastal application, or let's say the biggest application we have is the monitoring inside the harbor during the construction or during the dredging. So here you can see some example in harbor. Some of them are for the derocking in order to have deeper harbor to accept a bigger boat. Also, we have the construction of mega bridge in Réunion Island, for example. This mega bridge is built on the sea, and we have also the extension of harbor in order to receive the big machine of the windmill farm, for example. All of those applications, the need is to measure the impact and especially to measure the turbidity inside the water, to see what will be or what is the impact of those constructions on the field. So actually, we can say the half of the production, or 45% of the production is the application is inside the harbor construction monitoring. One of the applications as well is for fishing and oyster farm. As you know, this is a very sensitive culture inside the water, and it's very important to have some parameters in real time, like the temperature, the dissolved oxygen, and sometimes the turbidity as well. But the farmer need to get those information and to receive alarms, in fact, in real times, in order to do some modification on the farm. For example, when for the oyster farm, this is when the temperature is very important when during the reproduction of the oyster, and we install many buoys in order to measure this temperature in real time and to send all the parameters on the smartphone on the farmer in order to collect the oyster just on time. And finally, I would like to talk about the wind offshore environmental monitoring. As you know, when we do the construction of offshore windmill farm, there are a lot of impact for the fisheries, for the fishermen, impact for the environment, and not only the construction of the windmill by itself, but also when they have to install the cables, it can create some changes on the field. So by this way, we provide a complete system to measure those impact. We built an instrumented buoy for that with real-time telemetry, in some case by satellite, because it's far away from the coast. And each time it's also necessary to measure physico-chemical parameters. Again, the turbidity is the most important parameter that our customer want to measure. And for each application, each instrumented buoy that we are providing for this industry, we install WiMo multiparameter probe in order to measure different parameters like the turbidity. But here in this specific example for the Bay of Saint-Brieuc, we measure turbidity, salinity, pH, and chlorophyll A in real time, plus all the different measurements like the swell current and meteorological parameters. Everything is sent by satellite, and on land there is a specific development in order to provide on a website access or platform to provide the data in real time. The construction company can have also alarms depending of the level it's programmed for each of them. And it can have also the conditions for the vessels. That means the current, the wave, the wind, and so on. So those networks is very useful, and let's say this is the earth of the construction for them during this operation. So today it was a very brief presentation of different applications that we can do with the multiparameter probe. Of course, we do not have time to go in a deep description for all of them, but we are welcome to contact us. You can see my email address on the bottom of this slide. You can contact us also through our website, www.nke-instrumentation.com. And we will be glad to explain in details each application that we provide. And if you have any need, of course, feel free to contact us whenever you want. So thank you very much to be with me this morning. Next week we will have other webinar. We are providing a webinar or doing a webinar every week in order to keep the contact with you in this strange and let's say a difficult moment, but we stay with our customer, we stay in contact, and hope to see you soon. Thank you very much and have a nice day.